Welcome all to the National Alliance of Preservation Commission's March webinar, Substitute Material. I'm going to start that over. Welcome all to the National Alliance of Preservation Commission's March webinar, Substitute Materials on Historic Building Exteriors, Evaluation and Considerations for Use. This webinar is brought to you in partnership with the National Park Service. I'm Amy Sunny, and I'm the Director of Preservation and Planning for the Preservation Foundation of Palm Beach. And I'm also a Commission Assistance and Mentoring Program trainer, or camp trainer, with the NAPC. And I'll be serving as the moderator for today's session. I'd like to take a few moments to get everyone oriented to the webinar platform. Like other platforms, you have access to a Q&A, chat, and polling function, which are tabs at the top right of your screen. If you'd like to minimize them, click the downward arrow at the upper right corner of your screen. To bring them back up, there will be a blue chat button at the bottom right corner for you to click. To view today's presentation in full screen mode, hover over the presentation and click Full. If you experience any technical issues, please use the private chat function to send a message to the National Alliance of Preservation Commissions. This session is being recorded and will be available for on-demand viewing after completion. As a registrant, you will automatically receive access to the recording a few hours after the session is completed. And now for a few more housekeeping items. As you can see, continuing education credit instructions are listed on this opening slide. You can also find these instructions repeated throughout the presentation in the chat tab. We invite you to ask questions throughout the webinar. We will get to questions as time allows. To ask a question, please use the Q&A function on the right-hand side. If someone else asks a question you'd like to hear the answer to, give their question a thumbs up or upvote, and it will move to the top of the list. The National Alliance of Preservation Commissions is committed to providing a welcoming space that encourages collaboration, discussion, and the sharing of ideas and points of view. Please note that by attending, you agree to the following code of conduct: to exercise consideration and respect towards presenters and participants in your speech and actions, to attempt collaboration before conflict, to refrain from demeaning, discriminatory, or harassing behavior and speech, and to be mindful of your surroundings and your fellow participants. So before we get started with the presentation, we'd like to know a bit more about who is attending this today. So on your screen, you will see a poll that has popped up. If you take a moment to answer it for us, please. And I'll just narrate in real time. It looks like we have about 40 to 45% of the attendees so far are listed as preservation board members or commission members. We have also over 30% that are city staff. And then we have a good representation from state historic preservation offices, federal staff, nonprofit staff, consultants, and others. And please feel free to share in the chat if we didn't capture the category that best fits your position. So now that we know who's attending, I would love to introduce you to today's presenters from the Technical Preservation Services. We have John Sandor, Amy Elizabeth Ubel, and David Trait. So John, if you'd like to tell us a little bit more about yourself.
Yes, thank you. I've been with Technical Preservation Services since 1996, coming from a state historic preservation office, so I've had experience on both sides of that spectrum. And my training is in architecture and experience as carpenter is put to pretty good use, I think, in terms of the tax review that is the core aspect of my job, with technical assistance being the real passion here.
Thank you so much, John. Amy Elizabeth?
Hi, Amy. Thanks. And sorry for my very rude doorbell that just happened. I'm Amy Elizabeth Ubel. I've been with Technical Preservation Services for about 3 years now. Prior to that, I worked in both academic world as well as the private sector. And my background is architectural conservation, so it's wonderful to be able to be part of this.
Thank you. And last, I want to have David introduce himself and also tell you a little bit about the presentation that you're about to see.
Thanks, Amy. Hi, everybody. My name is David Traits. I've been with Technical Preservation Services for about 7 years now. Currently serve as a supervisory architect for the office there. I started my career in the private sector. I'm trained as an architect, did historic rehabilitation work there before shifting into the public sector by way of the city of Chicago. So I did work for the Landmarks Commission there. So certainly can appreciate the position that many of you are in that we have with us today. Appreciate all of you joining us, and our thanks to NAPC, Amy, Sunny, and Marie Snyder specifically for all the work that they've done to put this event together today. We're very grateful for the opportunity, and we're very excited to have this conversation with you all. We have about an hour of content today, and this is focused on the update to the Preservation Brief 16 that John, Amy, Elizabeth, and I had. We've had the pleasure of plugging away at this for quite some time now, and it's a labor of love, we'll certainly call it. And we're excited that we were able to publish the update in October, very early October of this past fall. And starting in January of this year, we have been doing an outreach initiative with various public webinars for various audiences. So we're very happy to be able to do this one with you all here today, specific to NAPC. So like I said, we have about an hour of content. We'll do an overview of everything that's happening in that updated brief and where we've come from and where we are today. And we'll take a look at a number of different materials specifically. And then we'll have plenty of time at the end of this to answer any questions that you all might have. And so we appreciate NAPC and the schedule that they've arranged for us to have that opportunity to dive into a number of those questions. So along the way, if you have those, please feel free to enter those in the Q&A chat, and we'll start to get that list together to address at the end of all three of our presentations. We'll work through those. So Amy, if you want to go ahead and take it away. And we'll
Absolutely.
look forward to that.
Thank you
Thanks.
all for the introductions. Thank you, David, for telling us a little bit more. Again, like David said, make sure you put your questions in the Q&A function. There's also handouts over on that same right-hand side if you want to be able to get the copy of the brief in case you need to follow along or take notes. So I'm excited for this as much as all of you are. So let's go ahead and get started.
The webinar today is part of the National Park Service outreach on the recent updates to Preservation Brief 16, the use of substitute materials on historic building exteriors. The full guidance document is available for download in digital format on the Technical Preservation Services website. We're going to break this down into 3 sections today. First, I will cover the basics of substitute materials, including the evolution of NPS guidance, the history and general concept of substitutes, and the various considerations for use. Amy Elizabeth will take us on a deeper dive into understanding materials, talking about the physical properties, visual appearance, and performance of materials. Then John will present a series of case study examples and how to apply the guidance to assess the use of substitutes for common building features. Before we get into the details of the current preservation brief, this timeline illustrates the evolution of NPS guidance related to substitute materials and how we got to where we are today. The original Preservation Brief 16 was published in 1988 and established guidance on the use of substitute materials on historic building exteriors. This was a valuable guidance document with general concepts and principles that have certainly stood the test of time. In 2007, following recommendations from the National Park System Advisory Board, additional guidance was developed to provide greater clarity to program users and implement program improvements. One of the resulting efforts was the Evaluating Substitute Materials in Historic Buildings guidance, serving as a companion piece to the original 1988 Preservation Brief, using the same general concepts that could be applied to building interiors. More recently, the treatment guidelines were revised in 2017 to incorporate additional building types and materials, reflecting contemporary and current best practices. The guidelines on flood adaptation for rehabilitating historic buildings were issued in 2021. Both of these documents, referenced here in the middle of the screen, utilized a recommended versus not recommended treatment format with more content related to the use of substitute materials and the Secretary standards. That brings us to the latest effort of guidance updates published in October of 2023, which included the Preservation Brief as well as the 2007 NPSAB guidance. Our intention was to bring the substitute material specific guidance in line with current practice, the 2017 treatment guidelines, and other existing guidance, which had already moved the needle on this topic a bit. The 2023 updates continue to recognize that flexibility may sometimes be needed when it comes to new and replacement materials as part of a historic rehabilitation project. Apart from the need to align the various existing guidance, we recognize the materials industry and the application of substitute materials has advanced significantly over the last 35 years. As you can see in the small sample here, there are many product options on the market today, some perhaps a little bit more radical than others. Not all products have a place in historic application, but it's important to understand the materials market is continually shifting, and our intention was to better reflect the opportunities and challenges of the industry in that updated guidance. Our discussion today focuses on the preservation brief and the use of substitute materials on historic building exteriors, and we'll take a closer look at a number of these material types. Now, to be clear, the updated guidance is not a prescriptive list of materials that we're saying should be used without careful assessment. The guidance is intended to be a framework for decision making for preservation professionals and practitioners relative to the standards. With that in mind, let's step back and consider where the concept of substitute materials comes from. There's a long and well-documented history of using affordable and common materials to imitate more expensive or rare ones. As an example, these images show 4 different types of historic materials that were commonly used as a substitute for carved stone. Starting at the far left image is an example of concrete block cast to mimic quarried stone. Metal products like cast iron, seen in the second image, were commonly used in storefronts across the country. Scored stucco on a brick structure was another way to cheaply imitate stone facades. And lastly, terracotta with varying glazing techniques provided a lightweight alternative to stone. The words imitative and substitute are often used interchangeably when talking about materials, whether we mean to or not, but there's an important distinction that we need to make. The concept of imitative materials is detailed in the 2017 treatment guidelines and can be described as materials that were often used in initial construction rather than later repair and replacement purposes. Imitative materials, while evoking other materials, usually had distinctive qualities of their own and were not always a close match in appearance to the historic material that they were meant to imitate. The images here illustrate one of the most famous uses of imitative materials. George Washington utilized painted wood with sand applied to the surface in order to evoke rusticated stone at Mount Vernon. The term substitute materials is used to describe building materials that have the potential to match the appearance, physical properties, and related attributes of historic materials well enough to make them viable alternatives when historic materials require replacement. And the key concept here is that the substitute matches the historic when replacement is necessary. Imitative materials are not necessarily appropriate for use as substitute materials because they may not sufficiently match as required by the standards. We want to briefly touch on a concern that often comes up with substitute materials, and that is the concept of integrity. It's important to note any replacement of a historic material with new material can diminish the integrity of a building to some degree, even if it's an in-kind replacement. Mount Vernon is a good example to help illustrate this concept. We know that over time, some of the wood siding has been replaced as part of a restoration effort. Even though the replacement wood matches exactly with sand applied to the surface, it's still new wood with new sand, and any new material can affect integrity. When considering substitute materials in context of the rehabilitation standards, we're talking about a greater material change with focus on the preservation of a building's historic character. Rarely would we expect to see a substitute material used in a restoration project. The original preservation brief noted 4 distinct considerations for using substitute materials, while also referencing general ideas of several others. In the update, we have formally included 4 additional considerations. Now, these are not new concepts, but the result of formally bringing current practice and prior guidance in line with each other. Combined, we have illustrated 8 considerations or situations where substitute materials could potentially be appropriate for use. We recognize there may be other unique situations that warrant consideration of a substitute, but these 8 are the most typical in our experience. It's important to note the standards provide for flexibility and give us room to make decisions. In our case, we're making decisions for the federal tax credit program, and this is how we approach substitute materials in context of our program purview. Your community may decide otherwise in terms of what considerations are appropriate for the use of substitute materials. So let's take a look at examples related to each of the 8 considerations outlined in the preservation brief. The first consideration is the unavailability of the historic material. Some manufactured materials that were used historically on buildings are just simply no longer made. A common example of this is asbestos roof shingles or siding. This 1924 apartment building had the original asbestos shingle roof on steep gables, a highly visible and character-defining roof form, as we can see in the lower left image. The asbestos had reached the end of its serviceable life and required replacement. As asbestos products are unavailable, efforts were made to find a substitute that could appropriately match the historic material that we see in the middle image. Unfortunately, at the time of the project, there were very few options available that could come close to matching the visual and physical characteristics of the original asbestos. If we think about this a little bit more carefully, asbestos shingle was a historic substitute for slate, so the visual qualities could be achieved by using the traditional material, which was feasible given the size of the roof on this building. The dimensions, the profile, and the color of the new slate were a good match to the historic asbestos. And given the unavailability of the historic roof material, an appropriate substitute could be considered in this case. The next consideration is the unavailability of skilled artisans or historic craft techniques. These issues are more likely when working with detailed elements like carved wood or carved stone. Modern technologies like 3D laser scanning have helped fill the gap of lost craft, but they can be difficult to implement on larger scale projects. As you see in these images, a high-profile project like the U.S. Capitol exterior restoration, deteriorated marble cornice brackets were replaced in kind utilizing professional stone carvers. In reality, most rehabilitation projects don't have the luxury of time to undertake this level of work. We're typically faced with the opposite end of the project spectrum, and the result is a consideration for the use of a substitute material. Some historic building materials were of inherently poor quality or were not durable. Common examples could be soft sandstone or brownstone, or perhaps more modern wood products. Many of you have certainly seen this type of comparison in the left image before. This is the stark 100-year difference between old-growth lumber and the modern equivalent, resulting in decreased decay resistance. The image in the middle shows a wood storefront where a piece of replacement wood frame is rotting at the base, likely from a lack of paint on the end grain before the board was installed. The surrounding historic wood elements outside of the red box remain in good condition. The image on the right shows advanced wood decay at a window frame and surrounding elements. This isn't to say that we shouldn't ever use wood. In-kind replacement may still be the appropriate treatment, but installation details, the exposure, and location should be carefully evaluated in making the decision of how best to replace these materials when needed. I should note this particular example starts to blur a little bit with the consideration of unavailable material. We can certainly get wood for an in-kind replacement, but depending on the historic feature and the means in which an in-kind replacement would be achieved, durability may be a genuine concern that leads to the consideration of a substitute material. Again, this consideration extends beyond wood and could be applicable to a number of traditional building materials, but this is just a common example that many of us have been faced with. A less distinctive secondary feature may have more flexibility in the replacement material and required match. However, the overall character should still be preserved. In this example of a late 19th century residential property, the new and existing porches and stairs received cellular PVC railing systems as secondary features on a rear elevation, as we see in the image on the right. Since these features are not readily visible from the street elevations that we see in the image on the left, the overall character of the building is well preserved. When constructing a new addition, using materials that evoke the historic material without exactly matching it can be an effective means of achieving the balance between compatibility and differentiation for new construction. In the wood frame residential building shown here, a new addition was constructed at the rear of the historic building. The use of fiber cement siding gives the addition a compatible character without having to replicate the exact lap exposure or board thickness of the historic siding. The standards for rehabilitation do not require a missing feature to be reconstructed. However, the use of a more cost-effective substitute material can often create the opportunity to undertake such work. As long as the work is substantiated by historic documentation, reconstructing a missing feature in a substitute material may offer a positive impact to the overall character of the building. This turn-of-the-century office building had been victim of a modern renovation that included recladding the entire facade and unfortunately demolishing the original decorative terracotta elements in the process, and we can see the aftermath of that in the upper right-hand image. Rehabilitation efforts removed the non-historic facade and replicated the well-documented missing features, utilizing a combination of traditional and substitute materials. Given the quantity and location, glass fiber reinforced polymer, or what we refer to as GFRP, was used for elements at the upper floors to restore the original character of the building, and we can see the result of that in the two post-rehabilitation photos here. Rehabilitation projects often trigger compliance with code requirements that were not in place when the building was constructed. Although building codes may often allow for the retention of historic materials and assemblies, substitute materials can offer an alternative in situations when the historic materials are non-compliant and cannot otherwise be reasonably retained. This is an example of a dense residential district consisting of late 19th century wood frame buildings on very tight lots. Non-combustible cladding materials may be required due to the proximity of a wood frame structure to the lot line and other adjacent buildings. And this is an example of a situation where a change in materials on the side elevations with limited visibility may be appropriate to meet code requirements. Depending on the building, this could impact a number of different features including siding, soffits, eaves, or other roofline details. Code requirements may differ for building types and locations, so documentation and a thorough understanding of the requirements is important when assessing the use of a substitute material under this consideration. It's important to note not every city or community will have the same priorities. You should assess whether unique code requirements exist for your community and take into consideration whether the use of a substitute material may be helpful in meeting those requirements. Last but not least is the enhanced resilience and sustainability consideration. You may find yourself with a project where it is necessary to try to minimize impacts on a building's historic character as much as possible while still adapting it to be more resilient. We typically see this situation in projects that are faced with wildfires, flooding, parts of the country that are prone to hurricanes or other extreme weather events. This industrial mill sits on the bank of a river that is prone to flooding, located within the established floodplain. The existing condition of the building prior to rehabilitation had historic window openings that had been previously infilled. As part of the rehabilitation for mixed residential and commercial use, those windows were proposed to be reopened. One of the unique challenges with this building, though, is the ground floor windows are located within base flood elevation, meaning that the anticipated height of a flood could potentially be higher than the sill of those ground floor windows. So the solution was to construct the ground floor window assemblies using aquarium glass and cellular PVC trim in order to withstand repeat flood inundation, which in turn allows for occupiable spaces within the historic building. The key here is finding a balanced approach that maintains historic character while meeting resilience and sustainability goals. And as I mentioned previously, these are the 8 considerations we have used both in practice and outlined in previous guidance that we have formally aligned here in the updated preservation brief. But that's not to say you couldn't find yourself with a unique situation in your particular project that would warrant discussion and consideration of something different than what we've listed here. Economic factors are often cited as justification for the use of a substitute material. The standards are inherently flexible and are applied taking into consideration the economic and technical feasibility of each project. However, cost alone should not be the only factor in assessing the use of a substitute. The historic character of a building must still be retained. But there are other factors that play into consideration, such as the cost of maintaining the historic material because it is too difficult or costly to access, or perhaps the frequency of maintenance the historic material requires. Maintenance is not the reason to replace, but it can be the reason to choose something different when you do have to replace it. The example on the left is an early 19th century church with many changes over time, to the point where it's not quite clear what material is still historic. Proposed work to the steeple includes reusing any material that is determined to be historic, and the rest will be rebuilt with a mineral polymer composite. The use of a substitute in this instance will offer greater dimensional stability and therefore longer finish life, which means reducing the frequency that repainting will be needed, which comes at a considerable expense due to the need to scaffold a building like this for access. Another factor of feasibility can be when an in-kind replacement material is found to be prohibitively expensive. In this instance, it may be reasonable to consider a substitute that offers an alternative and is a good visual and physical match. The example on the right is a 1930s nurses' dormitory as part of a larger hospital complex. The large masonry building had a historic slate roof that was not particularly distinctive in detail, but expansive in size. The cost of an in-kind slate replacement was prohibitively expensive, and a polymer slate product was able to accurately match the visual and physical characteristics of the historic roof. The overall character of the building is maintained, as is the character of the multiple building complex. Lastly, not all substitute materials are cost-effective replacements. Long-term durability and repairability are other important factors to consider in conjunction with initial cost. When making decisions at the local level, you may be faced with projects or perhaps entire districts where economic resources are limited. You may want to consider utilizing substitute materials depending on the building or architectural feature if it helps address your specific community's needs. As mentioned earlier, the considerations we outline in the updated brief are where we draw the line based on the federal tax credit incentive program in context of the rehabilitation standards. Now that we've covered the considerations for when you might use a substitute material, I'll turn this over to Amy Elizabeth to take a closer look at the characteristics of materials.
The options for potential substitute materials can be overwhelming with the sheer number and variety of available architectural products. Furthermore, products change over time as materials develop and the market changes. What wasn't an acceptable substitute material 10 years ago might be acceptable today. Additionally, there's no list of materials that always meet the standards. Products have advantages and disadvantages and must be evaluated based on the unique needs of the project. The search for a substitute material can be made even more difficult when you try to decipher the marketing and specification sheets provided by manufacturers who are just trying to sell their product. In order to help, Preservation Brief 16 provides an overview of commonly seen contemporary materials that may be appropriate for use as a substitute material. For each of these materials, the brief provides information on the material itself, including a description of the basic composition, its use and installation characteristics, any general manufacturing characteristics, and expected physical attributes. It's important to note that the attributes listed in the preservation brief are high level and certainly don't include all possible options that can be found in the market today. Additionally, just because the material is listed and discussed does not mean it is appropriate for use in all situations. You must evaluate the suitability of any potential proposed substitute material and determine if it is appropriate for use in your project. In order to help your decision making, the brief provides a list of properties for the potential substitute material. This list details the various properties that the material is known for, including characteristics regarding the composition, water absorption, flame spread, and insect resistance, among others. It also lists typical finishes that can be found on these materials and identifies areas where the material is commonly installed and any specific physical characteristics related to that usage. While the preservation brief offers information on potential substitute materials, the attempt here was merely to provide a vocabulary and framework that provides guidance. Just because we discuss the material does not mean it is appropriate for use in all cases. In order to choose a suitable substitute material, you must understand how any material and its potential substitute relates to and interacts with each other. What is the material made of? What advantage does it give? How does it absorb or retain water? Does it expand with heat or moisture? These and more are all valid questions. The amount and types of architectural materials available for purchase today can be dizzying. When looking to better understand the properties of architectural materials, it's easiest to think of materials as a long, slow, steady march towards a more sophisticated material. That's not to say a better material, but rather a material that imitates, decreases cost, adds resilience, or otherwise provides a quality that doesn't exist with another material. This puts the burden on the user to better understand the materials they have or may want to use. Sometimes a professional firm is needed to come in and give research, but a rudimentary understanding of basic material properties can shed light on how materials will relate to each unique situation, environment, and the surrounding materials. The timeline provided on this slide is intended to illustrate how materials developed over time. Earlier, simpler materials, such as wood, stone, and iron, occasionally needed additional properties to achieve structural or aesthetic needs. Concrete and terracotta were developed as alternatives. By the early 20th century, plywood, asbestos products, cast stone, and aluminum exploded into the market as lighter, less corrosive, and cheaper materials that required less maintenance. These materials were able to achieve these properties by being a more processed version of their natural, simpler counterparts. They introduced the use of adhesives and additives to achieve these new properties and to create a unique material. By this point in time, many of these materials are now considered historic materials in their own right and occasionally require the use of a substitute. But by the late 20th century and 21st century, knowledge and technology continued to hone in and develop how basic materials such as wood, stone, and metals could be processed and enhanced to create new alternatives to traditional building materials. Most of these new materials are considered to be composites. Composite materials are a combination of two or more materials with different physical and chemical properties that are combined to make a unique material. To make a composite material, base materials or fillers are combined with various binders and additives. Often the base material is a form of wood chips, cellulose fiber, or a mineral. These binders can be cementitious or polymeric, using adhesives or a plastic resin. This often creates a homogeneous material without the distinctive planes, textures, and features that are characteristic of stones, woods, and early metals. Usually, composite materials will be processed into a highly refined form, then heated and extruded or cast into specific shapes. This results in a more uniform appearance than what is found in more traditional materials. However, developing technology is able to create different forms, more nuanced colors, and colors that permeate the entire material or are veneered with other more desirable materials. You don't need to be a materials scientist to understand the basic properties of materials. Materials have three basic categories that define how they will react in an architectural setting: physical, visual, and installation and performance. Physical characteristics, such as permeability in stone that you see on the right-hand side of the screen, defines how far moisture can be absorbed into a material, but it will also describe if a product will swell in the heat or if it will be prone to biological growth. Visual characteristics shed light on how something will appear to passersby, and the installation and performance guide when something can be used in specific circumstances. When comparing a material and its potential substitute, it is helpful to understand how the materials relate to each other in each of these three categories. How are the dimensions similar or different? Is the texture the same? Do you need it to be the same? Will the materials shrink and swell with water, heat, or time? What is the service life of the proposed replacement material, and how does that relate to the one it might replace? It's generally recommended that any potential substitute material have similar physical characteristics to the material it is replacing. Physical characteristics that should be compared include dimension and scale. Is the material orthotropic, meaning does its behavior vary differently depending on the direction, or is the material isotropic, meaning it will behave the same in all directions? Porosity, or how much water can be absorbed in a material, and permeability, or how far moisture travels in that material, will vary greatly depending on if it is an older or newer material type. Most materials will swell and shrink with moisture, heat, and time. How will two unique materials work together or against each other? Some modern composites have different strength and support requirements. This can require extra or lessen additional support for the replacement material. Lastly, additives are intended to increase performance, but they don't always increase performance in perpetuity. Some, such as antimicrobials, only work for a short period of time. Others, such as UV stabilizers, may require replenishment. Visual characteristics can be some of the hardest to replicate. Is the surface to be painted or left unpainted? What was the finish historically? How close will observers be to the material? If something is on a cornice 20 feet from the ground, it likely will not require as close of a textural match than a feature that is at eye level. Similarly, color and the subtle color variations that are prominent features of stone, cast stone, and wood can be difficult, though not always impossible, to match with homogeneous manufactured materials. Though physical attributes dictate this last set of characteristics, installation and performance characteristics are important enough that they should be understood on a higher systematic level. The expansion and contraction of materials will require planning to ensure that bowing, sagging, or gaps do not appear where they are not intended to be. Some composites may increase durability in some physical aspects, but at the sacrifice of others. Does the material change how something should be adhered or supported? Lastly, many new materials may appear to have specific performance advantages over their traditional counterparts, but these characteristics may be only designed to work for a short amount of time. It can be difficult to determine the durability of any material, but especially so for new materials with a shorter track record. Warranties are not the same as service life, and the repairability and durability of both the historic and potential replacement should be understood prior to any decision making. For example, while tongue and groove flooring in a pre-finished style may be a cost-effective option, it can only be replaced, which may create larger and more costly maintenance cycles if placed in a high-traffic area. Additionally, many of you may remember that some earlier substitute materials from 30 or 40 years ago may have chalked, degraded, faded, or otherwise proved to be a less than ideal long-term solution. However, just because one product did that does not mean that all products will do the same into the future as materials continue to evolve. Now that you know everything about modern materials, you're ready to go. Well, if not, the preservation brief has pre-digested many of the physical and visual characteristics of potential substitute materials. The chart on the left is not comprehensive, nor is it a list of always acceptable materials. It's merely intended to provide a framework for you to make educated decisions on the appropriate use of materials in your unique project. Furthermore, the chart only reflects materials commonly considered for use as a substitute. The market will continue to change and develop in the upcoming years, and it is expected that materials may improve, disappear, or change. The preservation brief also provides a quick reference to the types of materials on the market today and where you might find them used. Lastly, we've provided a list of questions relating to the specific building features that are intended to act as a starting point for the evaluation of a potential substitute material in its particular application. These questions should help narrow down and eliminate what materials are and are not acceptable for use as a substitute material.
We've now looked at the various circumstances where it might be appropriate to consider using a substitute material. And then we've had an introduction to the properties affecting both behavior and appearance of materials that we need to take into account as we explore what, if any, substitute material may be appropriate to use. While the chart does match various classes of materials to the building features, where they may have some applicability, it should not be misconstrued as a list of materials that can always be considered appropriate for those features. The process of exploring a substitute material needs to begin with an assessment of the feature where the material is to be used. What has triggered the need for the replacement? What are visual and physical performance characteristics the new material needs to have? Now let's go through the various building features we have listed, looking at some specific substitutes, their limitations, and issues that affect their potential for success. When architectural features that are metal need to be replaced, it's often just a matter of turning to a different metal. If the feature is a painted one, such as standing seam metal roofing, the issues with the change will be less about appearance and more about the performance of the material. Thus, turn metal, no longer available, needs to become galvanized or enameled aluminum or even copper, as long as the profiles are the same and it's painted. The metal won't be the issue. Where different metals intersect, though, coatings or membranes need to be used to prevent galvanic corrosion. And of course, different expansion and contraction rates need to be taken into account when different metals are in the same assembly. A typical metal for metal substitute is cast aluminum for cast iron, as illustrated by the cast eagle depicted. An example of the use of a completely different material for metal is the replacement of missing cast ornamental elements that are part of the grille work inside the waiting room windows of the Michigan Central Station in Detroit. Here, 3D printing proved to be a cost-effective way to reproduce the needed repetitive elements. They are supported within the surviving metal frame and painted to match, and probably could have been the solution even in an exterior location. The soft red sandstone at the base of this 19th century building had not fared very well and was most likely a local stone no longer quarried and hard to match with stone from another source. The needed new pieces had to be inserted incrementally into the existing load-bearing assembly, making cast stone the appropriate choice. Thus, the similarity of the physical properties of the cast stone to natural stone are really quite important for this type of installation. Unique molds were used for each stone, capturing the randomness of rock face tooling. It's hard to distinguish the new material from the original without close inspection. Color, which is an integral part of the material, not surprisingly has remained a good match over 40 years since this work was done. Glass fiber reinforced polymer was used to replace the top element of the terracotta cornice of the Michigan Central Station on the left. Glass fiber reinforced concrete was used for the missing spandrels and other elements on the shipper block in Peoria on the right. Both offer great advantage for replacing terracotta or stone because of their typically shorter lead times and often, importantly, their reduced weight. The decay of the steel supporting terracotta is a big part of the deterioration of these features. When less substantial steel is needed to support the new feature, the potential need to disrupt existing masonry to make major structural modifications is reduced. These materials are particularly successful where an entire feature is being replaced. And the expansion and contraction of the materials, which are different from stone or terracotta, can therefore readily be accommodated. While we've used the term FRC in this publication, glass is the most common fiber used with concrete, and GFRC is the more frequently used shorthand for it. It has the advantage over GFRP in some situations of being fire rated, as well as having an expansion and contraction that might be a bit closer to that of stone. GFRP will always have a coating to create the finish of the material it is imitating. Color and finish can be a part of the surface of the material built into the manufacturing process, or may be applied post-production. Glass or fiber reinforced concrete may have color integral to the material, but it can also be coated, which is especially likely when a glazed surface is being reproduced. Though the coatings can last a long time, they do not have the permanence of color that is an integral part of the material. Traditional porch decks were nearly always constructed of tongue and groove boards, producing a continuous surface that was always painted. Subject to severe weather exposure, even the best constructed and finished wood porch floors have a finite lifespan, especially constructed with the wood that's readily available currently. 4 different materials are currently being used to produce tongue and groove porch decking: cellular PVC, mineral polymer composite, cellulose fiber polymer composite, and solid polymer or PVC. All are currently available as actual tongue and groove decking. Each material offers slightly different properties. Some are available only pre-finished with a capping surface material, eliminating the need to paint. Though long-lasting, these factory-applied surfaces are not usually suitable base for paint, which can be a limitation in terms of renewing a surface when it is worn. Other products are designed to accept paint, making their surface renewable and visually more similar to that of painted wood. Pre-finished material can reasonably be expected to have a bit of texture for slip resistance. When decking is needed for a porch or deck that is a new feature, or in a secondary location as illustrated at right, simple square edge boards available in even more choices of material can be considered appropriately compatible. If it's a location where the standard pressure-treated decking coated with an opaque stain or paint might be considered appropriate to use, one of these square edge composites could be equally suitable. If the pressure-treated wood would need to have a finish to make it compatible, then any composite material should not be one with bold grain pattern and a natural wood finish. This second-story porch is a pre-finished material that has held up well for the several years it has been in place at this Southern House Museum. What is significant about this installation is that the product chosen was acceptable to install directly atop a waterproof membrane, making the deck effectively a roof and protecting the ceiling below, as well as the structural framing itself, from water and its effects. Other tongue and groove products can also be installed over a membrane, but require intervening sleepers as part of the assembly to facilitate drainage. For any wood frame building, siding is a major contributor to its character, and where historic wood siding is in place, any needed replacement will need to be a good visual match. Though there were a variety of profiles used particularly in the late 19th century, basic lap siding or clapboard could be found throughout the country from the 18th through the 20th centuries. Its thickness and exposure might vary with the date and style of the building, but 4-inch exposure was fairly typical on 19th century buildings, whereas the siding with a wider exposure be something would be more commonly found on a 20th century house, maybe in the craftsman style. The thickness of the butt edge of a board could vary as well as its exposure, though the clapboard was generally no less than 3/8 and no thicker than 3/4 of an inch, with the wider exposures generally being at the thicker end of the spectrum. The photo on the left shows wood siding on the front of this house with a narrow exposure and a butt edge that is between 3/8 and 1/2 inch. The siding depicted on the sidewall of the house is fiber cement board with both a wider exposure and a thinner butt. Though the exposure could have been matched by increasing the lap, even if the exposure was the same, the effect would not be a match because the shadow line at the butt edge is so obviously less. The shadow line is a function of the thickness of the material, which is limited by what is available from the manufacturer and cannot be adjusted or custom ordered in any other thickness. For fiber cement, the wood and wood fiber composite, that dimension is typically 7/16 of an inch, though there is the 5/8 inch material available in cement board. Both of the widely available substitute materials are thinner than any traditional wood siding, and the thicker version of cement board is an option that's too thick to accurately replicate traditional wood siding that was used for the narrow exposure, such as 4 inches. When the thickness differential of the substitutes is discernible, it limits them to use on very secondary elevations or new additions. Some siding materials have a heavily embossed surface looking like a piece of wood that's been sandblasted, as depicted in the middle photograph. Some materials are available only with a smooth surface, and some offer both options. Since traditional wood was planed, only a smooth option is appropriate for replacing historic wood siding. Though one might create a board and batten siding from materials available as trim boards, the only other historic siding profiles available in a substitute material are beaded edge, that's in fiber cement, or cove or drop siding, available only in mineral polymer composite. None of these materials have the same properties as wood. Cement board is notably heavier, and the polymer and mineral one has less tensile strength, factors that affect the handling of the material in installation. But they can be less affected than wood by moisture, and can offer better fire resistance. The landmark home of Charles and Ray Eames in the Pacific Palisades utilized a painted asbestos cement board to face an insulated panel, used instead of glass in some locations in the steel frame. Panels that had previously failed, probably due in part to failing to coat the edges before installation, were replaced previously with a wood fiber-based panel, which has also failed. The original Cemesto panel, as well as the earlier replacement, are both depicted in the center photo. Replacements currently underway are using a fiber cement panel, closer to the material of the original. Given the importance of the property, sample installations have been done to understand the weathering and predict the long-term suitability of the new replacements. Polymer-based roofing shingles have become a popular replacement for slate roofs on historic properties and have great potential to create the visual effect of a slate roof with both durability and cost savings. Unfortunately, there are limitations to what is currently being manufactured that limit the appropriate application of this material. These polymer products are molded to mimic the irregular profiles created at the edges of real slate shingles when they are cut. Different manufacturers offer different shapes, but only one manufacturer offers shingles that are slates that are narrower than the 12-inch standard shingle that most are produced in. And then all the widths that they do offer are the same length, creating some inefficiency for matching smaller slates that have a proportionately shorter exposure. Other companies offer multiple widths only as a blend, intended for creating a picturesque or rustic effect. The visual effect of this size limitation is apparent in the photo of these adjacent row houses. The one on the left has its original slate roof, though unfortunately now painted. The historic roof consists both of square and chisel point shingles, not much more than 6 inches wide, and with a similarly short exposure. The synthetic slate roof on the right pretty closely matches the exposure of the shingles. It's easy enough to just overlap the material a little bit more, as with siding, but it's a little inefficient. If wasting material, though, was not an issue, one might wonder why the polymer slate were not just cut to width and shape as the real slate might be. The inset photo on the bottom illustrates the problem with cutting these shingles to achieve custom sizes and shapes. The material is easy enough to cut, but a cut yields a very crisp edge. which is in contrast to the molded edges that are designed to mimic the way natural slate breaks when it is cut. It may, however, be worth considering just how big a factor this edge appearance is at the distance from which a roof is typically seen. Would the edge profile really matter more than the overall texture created by the size of the shingle? For all of the effort to achieve a matching effect, the larger scale of the new material creates a significantly different appearance, giving the surface an overall texture that is inconsistent with the scale of the building. For the small amount of roofing needed for this prominent feature of the house, the savings resulted from using the substitute slate would not have been sufficient to warrant so great a change in character, especially in a high-value neighborhood in a large urban area where there is ready access to real slate and the skills to install it. For a large building like the block-long school on the left, a small difference in the size of a shingle has less visual impact than on a smaller building, and these larger buildings generally have larger slates in the first place. In such a case, there is little change in historic character with the use of this substitute material. However, the close-up inset of the school roof illustrates an issue that has plagued some products in this class, and that is slightly lifted edges. You can see there in that photograph. The manufacturers attribute this to failing to follow recommended installation procedures. But at any rate, it doesn't seem to affect the waterproofing function of the roof, but visually it's a little disconcerting. Other materials, including concrete and tile, are also used to mimic slate, but for issues that can include cost and weight, and for some of those products, rather poor imitative appearance as well, they're much less frequently considered. While we do not usually consider fiberglass-based asphalt shingles as a substitute material for slate, there are situations where some of the fiberglass products that are designed to evoke the appearance of slate do a better job of approximating the size and proportion of smaller slates than the polymer products. On the right-hand image, the right plane of the roof retains its historic slate, whereas the plane of the roof with the dormer has a multi-tab fiberglass-based asphalt shingle with a tab size and proportion that is very similar to that of the retained slate on the other side. The granular texture of the new shingle is not the material's most salient aspect at the distance viewed. The overall texture created by the size of the shingle is far more critical to maintaining the existing character than the surface texture of any individual element. Wood shingles have too short a lifespan to survive long enough to often become historic. Even when a building still has a wood roof, it's likely to be a second-generation one. Many projects are looking to reestablish the appearance of a wood roof long gone when it's known that that was the historic roofing material. Wood shingle roofs present a significant challenge for matching with any substitute material, though wood shingle substitutes are produced in both concrete and polymer composites. Because wood is a weathering natural material that tends to have a good bit of subtle color variation, choosing a substitute that is consistent with the weathered color of the wood without being too uniform in color will probably have the most convincing effect. Because of the fire risk of wood shingles, even if treated, the justification for using a substitute may be more readily made in a high fire risk area, especially if other risk factors to the building are being addressed. Most substitutes can have a Class A flame spread rating, if not being outright non-combustible. Just as fiberglass-based asphalt roofing is not similar enough to slate to generally be considered a substitute for it, neither are those fiberglass shingles that attempt to evoke wood shingles generally considered a good substitute for replacing an existing historic wood roof. But when the color is carefully selected, some products in this class may approximate the scale and texture of a wood roof adequately enough to be a choice where the roof for replacing a roof that was historically wood but has long been lost to asphalt shingles. The image on the right juxtaposes weathered wood shingles on a sidewall with typical small tab fiberglass shingles on the roof, illustrating how, at best, close in appearance these two different materials can be. Wood trim is typically a painted feature with a smooth painted surface, making many substitute materials with a smooth, paintable, or pre-finished surface appropriate to consider. None of the several possibilities behave exactly like wood, though, and understanding those differences is critical to using them successfully. In fact, the failure to use real wood correctly is responsible for its failure in many applications, as an image David showed earlier illustrated. Much historic trim was not designed to shed water the way most wood siding does, making it a feature frequently prone to decay. Moreover, trim typically involves a lot of joints with material oriented in different directions. Understanding the relative movement characteristics of the chosen material are critical to its successful use. Most of the substitute materials suitable for use as trim, unlike wood, are isotropic, and regardless of whether their expansion and contraction is driven primarily by heat or moisture, they will move proportionate to their dimensions, equally in all directions. For example, moisture will have no effect on the movement of a piece of cellular PVC. It will expand and contract with temperature change, though, but for a short section, that movement will typically be much less than the movement an equal-sized piece of wood will have across its grain as it wets and dries. By contrast, a 16-foot long piece of wood will not change in length noticeably from either heat or moisture, whereas an equivalent length of cellular PVC will change dimension enough with normal solar heat gain to require accommodation at the ends for the change or fasteners to resist it. The base of the bay window at the center of the slide makes good use of cellular PVC by its design. Most of the components are short pieces, and the longest ones terminate at corners where some expansion can be accommodated. Also, it's painted white, reducing the potential for solar heat gain. All of the materials listed as potential substitutes for trim can be painted, and in fact, except for the cellular PVC, must be painted if not available pre-finished. The tracery in the steeple at the far right illustrates the potential for cellular PVC to be shaped with woodworking tools. Most of these materials are available as moldings, typical of what one can find in wood, as seen in the beadboard and molding that are of a mineral polymer composite used in the soffit illustrated on the left. The isotropic structure of cellulose fiber polymer composites can make them ideal where wide pieces of wood are needed and wood boards would cup and plywood would require a lot of surface prep to get a paintable smooth surface. While less prone to movement with heat, it is subject to moisture-related movement. And being isotropic, it can move more than wood over a long dimension. Such was the case illustrated by the storefront base on the left. The material must not have been thoroughly dry when it was installed because it clearly shrank enough to merit some remedial caulking, done very poorly and ineffectively. Previous versions of this composite material have not always performed very well, so using material from a reputable manufacturer would be advised, and most importantly, following the manufacturer's advice about finishing and fastening. The need to coat cut ends before assembly was not understood in the otherwise successful use of the material for the porch post illustrated on the right, where one can see evidence of failure already emerging at the base of this column in the little inset there. This is damage one might have expected at the base of even a wood column that was similarly installed without sealing or painting its end. Cement board may be less frequently used for trim than other materials we have just looked at, perhaps because it's not as easily cut and cannot be easily shaped or worked with typical woodworking tools as most others can. It can successfully be used, as it was in this example, where it faces the exterior surface for a wall configured to create the appearance of an early vehicular door in this historic firehouse. Simple flat boards over panels were all that were needed to execute the design. Without the moisture-driven movement of wood or cellulose composites, or the temperature-driven movement of cellular PVC, it should provide a relatively stable assembly that will not be prone to paint failures. The material is not recommended for ground contact, so one might hope that the small concrete curb on which it sits is minimally adequate to prevent any moisture absorption at the bottom of the assembly. While much of our focus in the brief is about when it's acceptable to use a substitute material and how to evaluate what makes an adequate match, I hope some of these examples illustrate that there are no ideal materials, and what might be appropriate in one application could be unacceptable in another. The successful use of any of them, when it is decided they can appropriately meet the applicable standards, is dependent upon understanding their properties and following installation and finishing recommendations. If you are in a position to make decisions about the use of substitute materials, your life would be a lot easier if you just had a list of approvable materials. But I hope our presentation has illustrated why creating such a list is not an effective approach. Using a list to replace solution-specific evaluation would inevitably miss achieving some good replacement solutions while allowing others that either perform poorly or diminish historic character.
I'll jump back in here to help wrap us up today. Our intention in updating the preservation brief was to create a framework for decision making in addressing the material challenges all of us are faced with. So if you find yourself in the position of having to ask the basic question, is a substitute material appropriate? There are 3 important points we hope you take with you today to help make that determination. First is the need to assess whether replacement of the historic material is necessary. If so, then evaluate the amount and location of a replacement material in relation to the building's historic character. Then consider the appropriateness of a particular substitute material in terms of its appearance, physical properties and compatibility, and performance of the substitute material over time. Now we want to be clear that the updated guidance is not a blanket approval for the use of substitute materials. Ultimately, you have the responsibility to decide as a community where that line gets drawn. We're assuming the audience that we have with us today is representative of commissions with a broad spectrum of professional support. Some of you may have little to no staff, and others may have a considerable number of sophisticated staff on hand to help facilitate project review. So as you interpret the standards and MPS guidance to create ordinances or local design guidelines in your community, be mindful of the commitment that you're making in those. We know firsthand how much time and attention these material reviews and decisions may take. Do you have the staff support to follow through on that? And I'll say, even for us here at MPS with over 20 full-time staff, it's not easy. Facilitating technical reviews at a material level is not a simple task, but if you carefully evaluate all the factors that we've talked about here, as well as in the written guidance, you can make well-informed decisions relative to your specific historic resources and community needs. We thank you for joining us today, and at this point, we will take questions for the remaining time that we have. Thank you.
All right. Well, thank you so much, John, David, and Amy Elizabeth, for that great presentation. And also for all of your hard work in updating preservation brief number 16. The updated brief really builds nicely on the previous version that was done by Sharon Park and gives so many wonderful new examples and photos and text. So we're gonna go ahead and move towards the Q&A section of today's presentation. And I also want to take a moment to let all of the attendees know that there was an error. A lot of you mentioned that to us with some of the handouts, and that has been corrected. So you should be able to access those now, both the preservation brief number 16 and the treatment guidelines. And so as one of the first questions, I saw somebody ask, what is the difference between the preservation brief number 16 and the treatment guidelines, which are both linked in the handouts. So I'm going to turn that over to you all to tell them the difference.
Sure. The treatment guidelines is a much broader guidance document. It tackles kind of all aspects of the building and approach to those treatments in a recommended versus not recommended format. There's kind of tables that spell out what is a recommended treatment versus not recommended treatment. The preservation briefs are a more targeted guidance document specific to a single subject matter. And in this case, preservation brief 16 is substitute materials on exterior of buildings. So there are elements of substitute materials that get picked up and mentioned along the way in the treatment guidelines document but it is not specific to only substitute materials. It's a wide spectrum of preservation treatments that are being covered in that. So our efforts and what we, the three of us have been working on was that strategic update to the preservation brief specifically. We have not done any other work to the other documents that we reference. We only share those just as they're really good tools to be aware of and to utilize, in addition to the more targeted guidance document in the updated preservation brief for substitute materials.
Great. Thanks very much, David. And just a reminder to all attendees, if you do have questions, please put them in the Q&A section. You have to tab over from chat to Q&A. And then please remember to vote or upvote questions as they'll move to the top of the list. So I will try, I saw a lot of questions in the chat, so I'll try to switch back and forth. But if you still have a question that wasn't answered, please try to put it in the Q&A. So for you all, the first question that looks like it has received the highest number of votes is that the guidance changes with evolving materials. Is this an acknowledgement that people are going to use substitute materials and establish some control over them, or an acknowledgement that preservationists should consider new technologies?
Maybe I'll take this one, and I'll let John and Amy Elizabeth talk more about all the material specific questions. I think this one came up early in my presentation when we kind of talk about where we got to where we are today and why we did the update. And what we had realized was that the materials market has evolved so much since the initial brief was done in the 80s. And so, in terms of what our intention is for the update to the brief, we are acknowledging that people are using substitute materials in practice, and we have been doing so for a number of years now. And we're trying to acknowledge that there's still the potential for using those materials appropriately, and those materials have changed. They're not the same materials that we might be used to from the 80s, 90s, early 2000s. There has been a lot of shift in that market. So that was part of the first part of our effort was, hey, we got to kind of catch up with what's been happening here, because we're seeing these being used, and we need to kind of get a better framework for assessing these and making those careful decisions on whether it is appropriate to use those the latest version of these. And then the other part of that question is, or is our effort to acknowledge that preservation should consider new technologies? So it's that as well. And our point is that we should be open to whatever new technologies are happening out there, because those are driving some of those new materials options as well. And the example that we gave on that is, the U.S. Capitol and what they were doing. In that case, they utilized both traditional artisans and skilled stone workers and stone carvers, but they also were using CNC machines to help carve some of those elements. So we can really utilize and embrace both aspects of traditional and new technologies in some of these projects. And where do the substitute material questions come into that? So I think our intention was, let's bring ourselves up to date. What are those updated kind of parameters, looking at what we have been doing in practice, across the industry, and then also acknowledge what some of those new advancements have been.
I also think one of the points that we felt was necessary to make in the brief was really focused on things that are applicable under the rehabilitation standards, and where we were looking and seeing substitute materials in our practice day to day in reviewing historic tax credit projects. The original brief was very much focused on a kind of emphasizing caution, like don't use too much, be very careful, like you really shouldn't be using these things, but if we have to. And we were trying to take a more realistic approach, that it's not like it's good or bad, you just have to look at it for what it is, and really have reason to evaluate, or have the tools to evaluate it, and created some categories in when it's appropriate to use it that were not really articulated in the other brief. In some sense, an addition may not even be in the realm of substitute. It's something new, but in the end, we think of it that way when we're adding to historic buildings. So that was a whole category that we didn't even mention in the first brief. And the idea of dealing with the threats of flood and fire and other things that put buildings at risk for the building itself, that being too strict about considering substitutes in those situations needed to be acknowledged. So we were looking to expand the criteria when substitutes can appropriately be considered, given the changing world and the changing materials that we have to work to meet those challenges.
Great, thank you. Amy, anything you want to add on?
No, I think David and John really summed it up well.
All right. Well, then we'll move on to the next question, which I'm not even a little bit surprised to see has jumped quickly up to the top of your list, and it's about Windows, probably the number one question and discussion and debate of preservation commissions and anywhere at all times. So the question is, do you have any documents, or can you speak about the issue of window replacement? And then there's a few other questions that are similar to that that ask about what is the guidance on Windows, and what can you sort of give as not a recommendation for what to do in every situation, but what's out there for people to learn more.
Well, I think we could talk like twice this long if we were talking about Windows, and I've been known to do that from time to time. But we started off with this brief realizing the limitations of what we were trying to do, and did not include Windows or anything else that was really considered more of an assembly, not a single material that then you apply to make the assembly. So that's why Windows are not mentioned here, and why they really got their own category. I would say the guidance that's probably most useful now is on our website for David. Is it Making a Good Project Better, or it's under the Rehabilitation guidance, where we do talk about how to look at Windows and how to make decisions about whether it matches or doesn't match. And we look at Windows as we look at everything with a hierarchy, like where is the window? What can you see of it? What was the window that's there now? All those things factor into how much match and how much change can be accommodated. And when I first started in preservation, if you had a wood window and you told somebody to use a wood window, you probably didn't do too badly. Now, wood windows, to the extent that we still have them being made by major manufacturers, aren't really an exact match for a traditional wood window. And you sometimes can, if you're looking at profiles and dimensions, some of these other materials, aluminum clad wood or even all aluminum, can sometimes better match some of the shapes and profiles and dimensions that a wood window would have had. So if it's a painted surface, like, is it important that it be wood if it in the end doesn't look like the historic wood window? So windows become really a fairly complicated decision-making process because of the incredible variety among the different manufacturers and the different materials. And I think that the starting point for that really has to be looking at what you have and then trying to look at the individual unit that's being proposed and understanding what the change will be if that unit is used. And not to get too far off the line, because we're not talking about Windows here, but is that you need to remember that you have to ask the question, what are you replacing? And 9 times out of 10 in my neighborhood, where I live in a historic district, people don't take the old window out. They only take the sash out and they install a whole new window. Well, you've missed the boat if you're just worried about whether it's a wood window or not. You have to dig down and figure out what the real questions are that are necessary, which is how we need to look at substitute materials in the first place. It's like creating categories of this is or isn't acceptable just doesn't get you the result that we all want to have.
Kind of chiming in on top of all of that, because I did see at least one comment in the Q&A about our thoughts on EFIS. And so really looking at that as well, kind of reiterating, we had to make the hard decision between, we can't talk about everything, we can't focus on everything. And so looking at these assemblies, which add extra complications, it would get to be very difficult. But I do believe that our framework that we're giving in this preservation brief can help. We're looking at how materials play nicely with other things. How is the aesthetic impact? How is the physical impact? These are all questions that do translate over. They're not just one hyper-specific aspect. With all of that, I do want to plug on our website, which is Technical Preservation Services. It's just easiest to Google it. Our preservation by topic link, which I also think is in our handouts as well, that has information on lots of different types of guidance, lots of different types of systems, windows, everything you can kind of look at to kind of pull through there, see different case studies, see different examples to help guide your evaluation of some of these new materials that are coming out and will continue to come out.
Well, great. Thank you both. And I just want to point out too, I think going to the section that Amy Elizabeth just mentioned is incredibly helpful. There are also preservation briefs on windows, not necessarily replacement, but the repair and other things like that. So definitely check out some of the other guidance that they have. So hopefully that answers a lot of the window ones that we have so many people voting for those questions. So I'm gonna move on to the next one for you all, which is that substitute materials can well replicate the original at the time of replacement, but their concern is 60 years down the road when the material has failed and nobody knows why it was chosen to replicate the original. They might assume a polymer shingle roof was chosen without justification and in turn just use asphalt, steel, or whatever the newest invention is. How can we assure the reasoning behind the use of that substitute material is known to future generations?
Well, we can't assure that even when we use traditional materials. We're often looking at buildings that have a roof on them, a metal roof, and it may have been a wood roof to start with. Materials change whether they be substitutes or not over time, and it's not really our job at this point, unless if you're dealing with a house that has a historic structures report that's important enough to have that, or a building that does, that's a different matter. But when we're dealing with average routine buildings in historic districts, we're more looking at what we have now, because rarely does anybody's ordinance require restoration. You only require that you respect the character and the physical evidence that survives. And so you can't really get yourself tied up in a knot about what was originally done or why they did it. Generally, though, we like when we see somebody that's replaced a window with a multi-light vinyl window, chances are it's because the original window was multi-light, even if the bad window even the window replaced was bad. So I think we do need to think about what the choice might have been, but we can't know that, and we're not requiring that kind of documentation on almost any project. And all these materials fail, including the real ones, and 60 years later. So we don't, that's a dilemma that's not unique to the substitute realm.
I kind of like to tag in on that one because this is going to be my heart. This is where my heart is. As a conservator, I love the things that have the longest longevity, that have the most maintenance. These are things that I sing about, but I also work in a practical world. And it's important to understand that there's always the best case scenario, but the best case scenario isn't always achievable. It's not always doable for any number of reasons, whether it's economics, whether it's environmental, whether it's location-based. And it's important to kind of understand that sometimes those will take precedence over knowing the longevity of something. And that makes it a hard decision, but it's still a decision in a conversation I think that's very important for us to have today.
I'd also just add to, part of our review and how we facilitate the federal tax credit program is if we have existing historic material and it's going to be replaced, we do ask for the documentation to show us what you're seeing in person at the building to confirm that it is truly deteriorated beyond repair. And then we're looking at the careful match component of what a substitute might be and the documentation that goes with that in terms of dimensions, profiles, colors, those type of things. So that is all documented as part of our review files. So, I mean, technically speaking, in the future, someone, if they were to, look back at that and say, okay, we understand why that decision was made at the time, just like we look back at historic photographs and other documentation to see when things are missing, what would be compatible for that building as we're looking to do new treatments or replacements there. So I think the concern is trying to memorialize that in some process. It may be part of how your review system is of what you're asking for from applicants or building owners of what they're showing you in order to make that decision.
Yeah, absolutely. I want to add on to what David said and putting on my camp trainer hat and just say that as commissions, certainly when you're making those decisions, if you serve on the commission or your staff, that can be part of your findings of fact. It can be part of your motions. It can be part of your development orders. All of the information that you use in putting together your case and how you make those decisions, if it is in a district or in some sort of organized preservation program, you can make sure that that knowledge is passed on then, because communities have requirements to keep records. Those would be kept for future generations to possibly go back and look at. So great question.
And there's a surprising amount of evidence left on a building, even when you don't intend to. I mean, we kind of deal with that with roofing all the time. Asphalt shingles has been so universal for a long time, and they used to all be 3-tab shingles, but they replaced everything from slate to metal to wood. And then when somebody wants to put a new asphalt shingle roof on, we generally ask, like, well, if you're wanting to use one that's kind of very evocative of wood and not like a 3-tab shingle that we used to see all the time, there's no such thing as a neutral anymore. So what was the most likely roof on that building? If it was a late enough building that it was asphalt shingle, then you probably needed to use a 3-tab, not a one that looks like a small tab wood shingle. And if you want to use that one, you need to have some evidence that it was a wood shingle roof at some point in its past. Otherwise, if it could have been slate, then you need to choose a shingle that at least evokes slate. But at that point, we're really not talking about substitutes as much as we're talking about just general evocative characteristics. And that's all you can ask for if what you have there now isn't itself historic.
All right. So the next question that I see in the chat is that this person was told that if the home has original wood siding, they were told that if the wood siding is replaced with vinyl or a different material, that it would ruin the historic integrity of the home. Is this accurate? And then they continue to say that they see fiber cement board potentially being a good substitute. However, is it okay to use because it was part of an addition and not applied to the original structure? So I think that's relating back to one of the images you all show of the original wood siding and the fiber cement siding.
A couple of questions there.
There are. So who wants to take a stab at the integrity question? Would it ruin the integrity of the building?
Changing the material at all diminishes integrity. I think David made that point very well. If it's new material, it's not the original material. The point is, does it need to be changed? And if you need to replace a couple of boards, you're not going to use cement board to replace a half a dozen boards in the field of an existing wood siding. You can't mix materials like that very successfully. So usually the goal is to try to keep what you have and to repair it if at all possible. But if you replace it, no matter what you replace it with, you're diminishing integrity. It doesn't mean you've destroyed it. That's a threshold that we wouldn't pretend to decide to determine here. But as the image that I showed, where we had wood siding on the front and a cement board on the side, you can see the difference in the character. And if the character of your building matters, then I don't see how you could make that change and not feel that you had, integrity aside, changed the character of the building by putting on something that was shallower and had less of a shadow line, especially if you're doing it on a major elevation. Now, we sometimes accept those kinds of compromises where there's some change, but it's not profound. We're not going from 6 to 8 inch boards, but we may be losing some of that exposure if it's on a very secondary elevation. And as David's criteria pointed out when we went through the different circumstances, we'd welcome it on an addition because that's an appropriate place to make that distinction. Additions should not be absolutely replicative and undiscernible as being additions. So if the siding's a little thinner on an addition, it's hard to understand why we would need to object to it if it's a little bit different. David, do you have something to reinforce?
No, I think generally that the vinyl siding question comes is in that same vein in terms of thought. We see very little of that being proposed at this point. A lot of people are going to these more modern products, but the same thing applies. If we're looking at according to the standards, retention and repair is number one, unless you're proving that it has to be replaced. And then our point here today is if you're replacing it, it needs to match. So these other materials, vinyl, the fiber cements, the other fiberboard based products, are they an appropriate match? And that's what you really need to be looking at. And oftentimes they might not be. And so therefore, to John's point, certain locations, you might be able to have that flexibility to say it is maybe not as good of a match. And so maybe we're not as concerned there. But so I just wanted to circle back on the vinyl siding aspect of that question as well. It falls in the same category.
Well, I think too, if I could just add on the vinyl siding, the thing that we get wrapped up in, like, oh, the material is the wrong material, and we don't really look at it. If we look at how vinyl siding gets installed, you can't install vinyl siding and then put trim boards on top of it. Vinyl siding is installed to a channel that butts up against the trim. So if you look at it cumulatively at all the different things that are different about it, it tends to have a little cup to it it's not, because it's not rigid. Like if you don't worry about whether it's vinyl or not, look at it and can you tell it's different? And if so, if you can tell it's different, it's probably not appropriate to use for replacement. You have to be observant, and the observation needs to go beyond just the surface of what it is, but actually, how does the overall thing work when you're in an installed situation? When you look at a vinyl-sided house, how can you tell it's a vinyl-sided house? What gives that away to you? It's not because you've gone up and knocked on it or you've tried to light it or something. It's what you can observe. And if you can observe that difference, then it probably isn't the right thing to use.
So I want to be cognizant of everyone's time. It is 2:30, and also to let you all know we have a very active Q&A. I still have dozens of questions, so we could do Q&A for probably the next 2 hours. But I think maybe we could take just a few final questions, and then we'll wrap up. And this is clearly a conversation that many people want to continue. We did have a record high number of live participants on this webinar today, so thank you all for that. So a few here that I see that do have quite a few votes in the chat. So the first one is the cost of replacement versus the use of original a non-factor for considering a replacement? And then it specifically wants to know more about, how do you factor in economic considerations?
I had a whole slide on that in the very last part of my presentation. It is a consideration, and we take into account economic and technical feasibility in applying the standards. And cost of maintenance is not the reason to replace something, but it gives you there are factors to consider if you've determined replacement is necessary. So I think that's a really critical aspect to think about. It's not just the dollars. The dollars aren't driving the decision, but it's something to consider when you have to actually do the replacement. And there are also economic considerations based on the resource in the community and the district that have to go that get taken into account as well. Slate roofing is probably one of the most common examples of this, and one of the ones I highlighted in my slide. If you have a very large building with a very large roof, and it's not really highly visible, it's very simple in nature, it is very expensive to replace slate in kind. So is that a situation where you might say the overall character of the building can be maintained and preserved by utilizing a substitute for slate? Because at the end of the day, it is more affordable, and we can at least capture that same character than going, losing it and having to go to like a 3-tab asphalt product. That may not be the appropriate jump to make, but there are more appropriate substitutes to consider. There may be situations where a slate roof is highly visible, highly detailed, and it's not appropriate to say, even though it costs a lot of money, to go to a substitute material that doesn't quite match. So it absolutely is a consideration to take into account, but it's not the driver in the decision-making, but it is something to be mindful of.
I think it's a little different for our program where we have nobody has to use the tax code. It's an optional program. But when you're dealing with communities that are mandated to follow your regulations, you have to be, I think, mindful, especially when you're dealing with some listed communities that may not be the most well-off communities, that you can't ask people to do something to keep their house standing that costs more than the house was worth in the first place. And I think looking at that value for the review commissions is inevitably one that would make a lot of sense to use, even if it's not the kind of criteria we would use for the tax credit program.
All right, so I think we have time for one or two more, and I'm going to go ahead and jump to this. The one that has moved to the top is, will the PowerPoint also be available? And I can go ahead and share that the slides are not going to be available. However, as I said in the beginning, you will be able to access a recording of this, and you have the handouts, and this presentation was based on Preservation Brief number 16, which is absolutely available to everybody. And then maybe to wrap up in the questions, I thought this was interesting. The question is about if a property has original cedar siding that's deteriorated, would replacing the wood siding with a synthetic be appropriate? I think you all have answered that part of it, but it goes on to ask, if so, should the original siding be retained under the new siding, or can the original siding be removed and replaced by the new materials? So just wondered if you all wanted to weigh in on the idea of covering it over versus just replacing it all together.
I think that would depend upon how your trim is going to work, and if you're thickening up the wall by doing that, it might not. Usually, you need to have a vertical nailer that you're putting siding on. If that means thickening out the wall, there may not be a lot of reason to do that. It comes down to the very specifics of your application, but I don't think saving it just because to bury the history is a nice idea, but there might be better ways to keep that evidence in place than keeping it if it doesn't lend itself to a good installation. You certainly you don't want to compromise your new installation for the sake of saving something that's old. And David, can we not tell people that there's another public webinar if people want to hear this thing again? That
Absolutely, yeah.
Crack at the nut, but
absolutely.
That'd be my final plug here for today. So we're doing one more public webinar that we're hosting on April 25th. It's a Thursday, and that will be at 2 p.m. Eastern. You can go to our website and under our webinars tab, you can find the registration link there. It'll be very similar presentation to what we gave today. So if you know other people or other colleagues that weren't able to join us today and might not be able to see the recording here, there is another chance to sit through the presentation as well there. And I just wanted to note, Amy, too, the reason why we can't share the PowerPoint presentation is that as a federal agency, we are required to comply with 508 compliance law, in which case that presentation does not meet those requirements. So we're happy to do this for you all today, and an NAPC can share the recording, but unfortunately we are unable to share the actual presentation materials. But we are also working on a version of this that is 508 compliant that will eventually live on our website as an on-demand webinar. So in the future, that will be an opportunity and a tool available to everybody as well.
Great. Thank you all. Well, like I said, there are still dozens of questions in the chat, so we'll have to save those for a future Q&A time. And I just want to take a few minutes to wrap up with some closing remarks. Thank you all for joining us today. Thank you so much to our presenters for such a great and an enlightening presentation and for all of your great answers to the questions. And if any of you would like to continue the conversation about substitute materials and other current topics in preservation, I'd like to invite you all to join us in sunny West Palm Beach, Florida this summer for NAPC's biennial conference, the Forum Conference. And the registration and the hotel room block actually opens in less than 2 weeks on Wednesday, April 3rd. And so as a West Palm Beach resident myself, I've been serving on the local planning committee, and I can tell you that we have some amazing educational sessions, special events, tours, workshops, and lots of other things planned. If you haven't previously attended Forum, I think that it's just an absolutely wonderful experience to really get enriching, specific technical sessions that deal with the work that we do every day as preservation professionals. And I just encourage you all to potentially take advantage of that opportunity. And you can check out the Forum webpage to learn more. Also, it's not too late to submit a nomination for NAPC's Commission Excellence Awards. The deadline is tomorrow, but it is easy to complete, so I hope you'll consider that as well. The award recipients do receive a free registration and a short video highlighting their work and a beautiful framed award. If you have any questions about Forum, the registration, the hotel accommodations, or the awards, please reach out to NAPC at director@napcommissions.org. All of today's attendees for the live session will automatically receive a certificate of completion via email later this afternoon. If you did not see it by Monday morning, please be sure to check your spam and promotions folders. And if you're watching it on demand, you will automatically receive a certificate of completion when you complete the recording. And last, we hope that you will attend next month's webinar, Preservation Synergy, Unlocking the Power of Nonprofit and Historic Commission Collaborations. More details will come to your email inbox soon. So if you're not already a member of the NAPC, consider joining today for access to free webinars and many other great benefits all year long. Thank you all for being with us. Thank you to John and David and Amy Elizabeth. And I just want to wish you all a pleasant rest of your afternoon. Take care.
Thanks, Amy.
Thank you.